Hi, for solutions of numerical number 1 to 10, please check the links in the description below. So numerical number 11 here is a combination consists of 3 resistors in series. So let me first draw 3 resistors in series and 4 similar sets are connected in parallel. So this is set number 1, this is set number 2, set number 3 and set number 4. These 4 sets are connected in parallel with each other, and the resistance of each resistor is 2 ohm. All right, so 2 ohm, 2 ohm, 2 ohm. So likewise all resistors in each set are of value 2 ohm. Find the equivalent resistance of the combination. So if we focus on set number 1, okay, just on set number 1, resistors are connected in series in set 1 and all resistors are having equal value. So we can use this formula, Rs is equal to N times R1, that is N is number of resistors, 3 resistors in series and each resistor is having value 2 ohm. So equivalent resistance of set 1 is 6 ohm. Let me label this as R1. Similarly, we can say for set number 2, R2 is 6 ohm. For set number 3, R3 is 6 ohm, and for set number 4, R4 is 6 ohm. Okay, so equivalent circuit diagram can be redrawn like this. 4 resistors connected in parallel and each resistor is having value 6 ohm. So now 4 resistors of equal value are connected in parallel. So we can use this formula, Rp is equal to R1 by number of resistors. Total number of resistors connected in parallel here are 4 and the value of each resistor is 6 ohm. 6 by 4, that is 3 by 2, 1.5 ohm. Alright, next question. In the circuit shown below, calculate the value of X if the equivalent resistance between the points A and B is 4 ohm. So first let me label these resistors R1, R2, R3 and R4. So from this circuit diagram we can conclude that R1 and R2 are in series. Let me call the equivalent resistance of R1 and R2 as R dash, and R3 and R4 are in series. Equivalent resistance of R3 and R4 is labeled as R double dash. So R dash, R double dash, and then as you can see here, R dash and R double dash are in parallel with each other. Alright, so let us first find out what is R dash and what is R double dash. R dash will be 4 plus 8, 12 ohm. R double dash is X plus 5 ohm. Now R dash and R double dash are in parallel. So I can use the parallel combination formula to find the equivalent resistance. So 1 upon Rp is equal to 1 upon R dash plus 1 upon R double dash. And the equivalent or the final resistance is given 4 ohm in the question. So we can say 1 by 4 is equal to 1 upon R dash is 12 plus 1 upon X plus 5. So let us simplify now. 1 by 12, sorry, 1 by 4 minus 1 by 12 is equal to 1 upon X plus 5. This is LCM 12, 3 minus 1, 2 upon 12 is equal to 1 upon X plus 5. 1 by 6 is equal to 1 upon X plus 5. So now on cross multiplying, we can get X plus 5 is equal to 6. So X is equal to 1 ohm. So the value of unknown resistance connected in the circuit is 1 ohm. Numerical number 13. Calculate the effective resistance between the points A and B in the circuit shown in the figure below. Alright, so now we want to find out RAB here. RAB. So let us start moving from point A towards point B. Now as we travel from point A to point B, the first resistor, okay, the first resistor is 1 ohm. But when we reach to this point, let me label this point as point C and this point as D, E, F, G, and H. So as we travel from A to C, from point C onwards, you can see that the current can flow in different directions. Okay, current can divide from point C. So point C is known as what? A junction point. So from point C onwards, the current takes three different paths. Path 1 is C to D, D to E, E to F. Path number 2 is C to F. Path number 3 is C, H, G, F. Alright, so we can say that between points C and F, there is a network of resistors. There is a network of resistors which we must simplify first. Okay, so we must simplify this network of resistors, and then only we can find out the final answer. To simplify the network of resistors, we must first identify paths between the 2 points. Okay, and we have already identified 3 paths. So all identified paths are always in parallel, and all resistors on a given path are always in series. So if you follow path number 1, that is CDEF, CDEF, as you can see there are 3 resistors on that path, 1 ohm, 1 ohm and 1 ohm, and they are in series. So let me label R1, equivalent of path 1 as R1, that is 1 plus 1 plus 1, 3 ohm. On path number 2, equivalent of path number 2, that is C to F, there is only one resistor. So that is already simplified, 2 ohm. And on path number 3, once again, as you can see that there are 3 paths, 3 resistors. Okay, so 2 plus 2 plus 2, 6 ohm. This is the equivalent resistance of path number 3. Now, as pointed out here in this point, all 3 paths or all identified paths are always in parallel. So we'll have to find out the equivalent of these 3 paths. That is 1 by 3 plus 1 by 2 plus 1 by 6. LCM is 30. 10 plus 15 plus 5. That is 15 plus 5, 20 plus 10, 30. 30 upon 30, 1 ohm. So Rp is equal to 1 ohm. Alright, so equivalent resistance of this network is 1 ohm. So now we can redraw the circuit diagram like this. A to C, C to F, F to B. Between A and C, 1 ohm. Between C and F, 1 ohm. Between F and B, again 1 ohm. And now as you can see from A to B, all 3 resistors are connected in series. So R equivalent is 1 plus 1 plus 1, that is 3 ohm. This is the final answer. Next, uniform wire with a resistance of 27 ohm is divided into three equal pieces and then they are joined in parallel. Find the equivalent resistance of the parallel combination. Okay, so a uniform wire, meaning a wire is having uniform cross section throughout its length. So let's say this is the wire, it has uniform cross section throughout. The resistance of this particular wire is 27 ohm. So this resistance 27 ohm can be written as rho L upon A, where L is a length, A is a cross section area. Now if we divide this wire into three equal pieces, so if we divide this wire into three equal pieces, okay, each piece will have length, each piece will have length L dash L by 3, okay, one third of the original length, because we are dividing this wire into how many parts? Three equal parts. So the length of each individual smaller piece is L by 3, one third of the initial length. But as you can see here, we are just, cutting the wire. We are just chopping the wire into three equal parts. The area of each smaller piece remains same as the area of the original wire. So here we are not stretching the wire. Here we are not compressing the wire. Okay, we are just cutting the wire. That is why its area of each smaller piece will be same as the area of the initial original wire. So there is no change in the area. So here resistance is affected only by the length, and we know that resistance is inversely proportional to length, and since length becomes one third, resistance, new resistance also must become one third of the initial or original resistance. So that is 27 by 3, 9 ohm. Alright, so now these three pieces are connected in parallel, and the resistance of each smaller piece is how much? 9 ohm. 9 ohm, and third one is also having 9 ohm. So now we can say Rp is equal to R1 by 3, 9 by 3, 3 ohm. So this equivalent resistance of this particular combination will give us the answer 3 ohm. Numerical number 15. A circuit consists of resistor of 1 ohm in series with a parallel arrangement of resistors 6 ohm and 3 ohm. Okay, so there is 1 ohm resistor that is in parallel with 6 ohm and 3 ohm. Calculate the total resistance of the circuit and draw a diagram for the arrangement. Alright, so diagram is already done. Let me label the resistors R1, R2, and this is R3. So first R2 and R3 are connected in parallel, so we must simplify them. 1 upon Rp is equal to 1 upon R2 plus 1 upon R3. 1 by 6 plus 1 by 3. LCM is 6, 1 plus 2, 3 by 6, 1 by 2. So Rp is equal to 2 ohm. So that 2 ohm is in series with 1 ohm. 1 ohm, 2 ohm. So the total equivalent resistance is now simple addition 1 plus 2, 3 ohm.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.